In this lesson, we're going to look at the isotopic symbol, mass numbers, and how we determine the number of protons, neutrons, and electrons in an atom of a particular element. In the previous lesson, we talked about the atomic number, or the number of protons, and that's always shown as a subscript before the symbol. We also have a number on top, which is called the mass number. And for this particular atom, the mass number is 9. This is what's known as an isotopic symbol. Remember that the atomic number is the number of protons. So if I'm looking at an atom of beryllium, it has an atomic number of 4, so it has 4 protons. The mass number actually shows us the number of protons plus neutrons. And this is always a whole number. We never have a decimal for either the mass number or the atomic number, because we're counting the number of protons and neutrons, and they always exist as whole particles. So in this example, we have 4 protons because our atomic number is 4, and we see that we have a mass number of 9. So the number of protons plus the number of neutrons equals 9, and if we know protons is 4, then we know that the neutrons are equal to 5. So an atom of beryllium-9 has 4 protons and 5 neutrons. What is the mass number of nitrogen-15? So 15 is correct. Note that when we write out nitrogen-15, that is always equal to the mass number, because the mass number can vary. And we'll see an example in a minute how elements have different isotopes or have a different mass number between elements of that substance. However, the atomic number can never change, because if it's nitrogen, the atomic number must be 7. 15 is the mass number, and so that equals the number of protons plus neutrons. Let's look at carbon-12, carbon-13, and carbon-14. All of these species have a neutral charge, and these are what we would call isotopes of carbon. If I zoomed in on a sample of carbon, I would not see that every single atom was exactly the same. I would see differences there. So when I look at these samples, carbon-12, carbon-13, and carbon-14, these all occur in nature. The majority of those carbon atoms will be carbon-12. We can see it's almost 99% of those atoms are carbon-12. Carbon-13 is about 1%, and carbon-14 is a very small amount. What is the same on all 3 of these? They all have 6 protons, which indicates that they are carbon. So they're all carbon, but what is different about them? So they have a different number of neutrons. Isotopes are atoms of the same element with different numbers of neutrons. So carbon-12, 13, and 14 all exist naturally. They all have 6 protons, but they have different numbers of neutrons. Therefore, their mass numbers will be different, and that's why we see carbon-12, carbon-13, and carbon-14. Carbon happens to have 3 naturally occurring isotopes. Every element has its own number of naturally occurring isotopes. Some only have 1, some have several. Another example is lithium. It has 2 naturally occurring isotopes, lithium-6 and lithium-7. Just like before, we're going to have the same number of protons, but a different number of neutrons, and therefore we'll have different mass numbers for lithium-6 and lithium-7. How many protons are in an atom of lithium? Notice that these both have an atomic number of 3, so they both have 3 protons. That's what makes it lithium. How many protons are in an atom of nitrogen-15? The atomic number is 7, so it has 7 protons. The atomic number equals the number of protons. How many neutrons are in an atom of nitrogen-15? So we have 7 protons, which we determined on the previous question, and we know that the protons plus neutrons equal the mass number, which in this case is 15. Therefore, we can solve for the number of neutrons and find that we have 8 neutrons. We've talked about protons, we've talked about neutrons, now we need to talk about electrons. So when we have a neutral atom, it means it has an equal number of protons that are positively charged and electrons, which are negatively charged. And how do we know this species is neutral? Well, it doesn't show us the charge. If there was a charge, it will be shown here in the upper right. So it has to explicitly show that charge in order to be there. So if nothing is shown, we know that that is a neutral species. So let's determine the number of protons, neutrons, and electrons in this particular atom. So we'll start with protons. We see our atomic number is 4, so we have 4 protons. For neutrons, we need to use the mass number, which is equal to the number of protons plus neutrons. We know there are 4 protons, therefore there must be 5 neutrons. And because this is a neutral species, the number of protons must equal the number of electrons. So we also have 4 electrons. How many electrons are in an atom of nitrogen 15? So it is neutral because there's no charge shown. Remember, if there's a charge, it has to be explicitly shown on the symbol. So when we look at our protons, neutrons, and electrons, we say there's 7 protons because the atomic number is 7. We have 7 electrons because the number of protons must equal the number of electrons in a neutral species. We will talk about cations and anions, which are positively and negatively charged species later on, and in those cases, the protons won't equal the electrons. But right now, we're only dealing with those neutral species. We also previously determined that this had 8 neutrons based on the mass number. What is the isotopic symbol of an atom with 11 protons, 12 neutrons, and 11 electrons? The first thing we're going to do is summarize the data, so we're not having to reread this. So we have 11 protons, 12 neutrons, and 11 electrons. Now we need to go from that information to building the isotopic symbol. So we know that it is a neutral species because it doesn't tell us anything about a charge. We know that the atomic number must equal 11 because the number of protons is 11. And we know that the mass number is 23, and we find that by adding the number of protons and the number of neutrons. Now we can build our symbol. So we have 23 in the superscript, 11 in the subscript, and then we'll put the chemical symbol in. We haven't talked a lot about the periodic table yet, but if we have 11 protons, that is for the element sodium, which has the symbol Na. For example, we have chlorine 35. There's nothing in the subscript there. So how are we supposed to know the atomic number? Well, we get it from the periodic table. So we always have the periodic table available to us. You don't have to memorize the periodic table. We will have some elements where you need to know the name and symbol just because we use them a lot and it makes things more efficient when you're solving problems. However, none of the values have to be memorized. So we'll have our periodic table. We know that we're dealing with chlorine. We find chlorine on the periodic table and we can look up its atomic number and therefore know the number of protons. With our mass number, which doesn't necessarily come straight from the periodic table, we can figure out the number of neutrons. So the mass number does not always equal the atomic mass. So we're going to see this average atomic mass on the periodic table. So for chlorine, for example, you'll see 35.45. And that's because there's a mix of isotopes. There's chlorine 35 and chlorine 36. And together, their average atomic mass is 35.45. When we're looking at isotopic symbols, that mass number is always a specific version of that element. So we're looking at chlorine 35 here. We could also look at chlorine 36. We will never see chlorine 35.45.